4 by 5, q 4 by 5, p is equal to 1 minus q, 1 minus 4 by 5, which is equal to 1 by 5. So what else is left over? P you have found, q you have found. What else is left over? N is left over. So what is how to get n? So from the first one you can substitute np, n into p minus pq, p minus pq. Rather you can substitute is equal to 0.2. N value we don't know, p value you know already, 1 by 5. P into q is 1 by 5 into 4 by 5, which is equal to 0.2. N into 1 by 5 minus 4 by 25 is equal to 0.2. N is equal to 25 into 0.2 divided by 25 minus 4, 1. 5 minus 4, 1. So 25 into 0.2. How much is that going to be? 5.0. N is 5. 5.0. N value is 5. So you are asked in this question what? Three things are asked. What are they? Parameters. N is found, P is found, Q is found. That's all. The solution is complete. Check. The only idea you should get here is when you are having these two relations, when these two relations are divided by one by the other, you can get rid of NP, you will be able to find Q. If that particular idea comes, the entire solution becomes easy. In the random, in this binomial distribution, question number 5. For a binomial distribution, mean is 10, variance 5. Variance is 5. Find probability of x greater than 6. Check. Always have a, this is question number 5, always try to understand, you have to go from the backwards, reverse engineering what we call it. Reverse engineering is what is to be found. What is to be found? You have to find probability of x greater than or equal to 6. What is the distribution function? NCR, P power R, Q power N minus R. So you should know N, you should know P, you should know R. You should know Q. Nothing is given. P is given, nothing is given. So what is the solution now? You have to first to find out N, P, Q. So what is given? Mean is NP. NP is 10. NPQ variance, which is equal to 5. This is called 1, this is called 2. When 2 divided by 1, you are going to get NPQ by NP, which is equal to 5 by 10, which in turn is equal to half. NP and QO. So Q is equal to half, P is equal to half. Take the value of P here and substitute in 1. So what you are going to have? P is half into P is equal to 10. So P is equal to 20. So P's value is half. That's why N is 20. So you are substituting for P. So N is equal to 20. N 20 you got. So N value you got, P value you got, and this one. Probability of x greater than 6. Probability of x greater than 6 means here also the desired event and complementary event are to be found. So you will have summation R is equal to, from where you have to get R greater than or equal to a, check. Probability of x greater than only, x greater than 6 means R should start from 7. It can go up to where? Up to the maximum of N, 20. NCR, okay? NCR, P is how much? P is how much? Half. Half power N minus R into Q is how much? Half. Half power R. Half power R. Now, if these two are simplified together, they will give you half power N. Yeah, N is already how much? 20. 20 minus R, let us write. 20 minus R plus R, which is equal to 20. So that is nothing but a constant because it is free from what? Free from R. So R is equal to 7 to 20 NCR. So this is your required answer, which is probability of X greater than 6. Okay. So let us redo the question. What is the question? Mean given, variance given, probability of X greater than 6 is being asked. So first use NPQ, divide one by the other, arrive at Q, find 1 minus P, 1 minus Q is P, then use the probability distribution. Note that X greater than 6 mean you should start from 7. You can go up to where? 20. And what is this step about? This step is here 1 by 2 power 20 has no R, that's why it can be written outside. Now we are taking up the second theoretical distribution, which is known as Poisson distribution. The Poisson distribution was independently arrived, but we are studying it as the limiting case of binomial distribution. When a binomial distribution will be converted into, or rather applied as, Poisson distribution, when first condition n is sufficiently large. What is n? The number of trials. The number of trials are going to be very, very big, huge. As a matter of fact, we are not able to exactly tell how many number of trials are there. Such case can happen. I will show you one example. Consider all telephone calls made. Telephone calls are made at this instant. And for that particular, all the telephone calls, how many are made in that instant? Largely huge number of calls. Among those, how many are being received by one particular number? For example, 9989191919. Such a number. How many calls are coming to this? So what is our exhaustive cases? Very large in number, and the success is very small. How many calls can come to this? Well, compare the quantity to the number of calls generated in a particular instant. So success are very small. But this NP, when this large quantity is multiplied by this smaller quantity, you are getting a quantity lambda which is finite. In this case, such cases, the binomial distribution can be applied as a Poisson distribution with a new distribution function. Okay, this is the background of Poisson distribution. So only 2 points. What are the 2 points? The number of trials are sufficiently large, and what is the end? What is the maximum number of trials? We are unable to find out. And success are what? Negligible. And when NP is found, that lambda is coming out as a constant which is fixed, then the Poisson distribution follows. As usual, they can ask you, define a Poisson distribution, variate or variable. Poisson variable. So what is the solution? Answer. What is the answer? Let lambda greater than 0 be a real number, and x has a range 0, 1, 2, 3 up to infinity. If you observe, this range was for binomial distribution up to n only. Now, and the probability of R successes is given by probability of x is equal to R lambda power R by R factorial into e power minus lambda. This is known as what? The theoretical